Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with 17103. Alright, so what we're looking at, we've got this object here accelerating 5 foot per second given in the problem. And what we're going to be looking for is the reactions exerted here on this object and the acceleration of this object at the instant shown. Now you might say, well, the acceleration should be 5 foot per second. Well, that would be true if this thing were rigid here, but it's not, it's pinned. So what's going to happen is that this thing basically is going to start rotating kind of counter or clockwise with respect to this. So this thing's going to have kind of an angular acceleration and a tangential acceleration at the instant shown. All the action is about the disc-shaped geometry, so I'm going to start this by drawing a free body diagram of the disc. And you'll notice that I'm drawing, I've copied it twice. That's because I'm going to have one picture for all the forces, one picture for the inertial terms, the MA terms and the I alpha terms. Okay, so force vectors. So let's see. Gravitational force looks, relevant in this problem. So we might put a force vector on that guy, mg down. Now this thing is supported at this pin. The force direction at the pin is not directly known, so what I'll do is I'm going to put a pair of forces here. I'm going to go ahead and call one maybe something like px and the other one py. So py, px, you could also call them maybe ax, ay, something like that. And again, it's one single force vector, it's just that the direction at the instant shown is not known, so it's quite common to just put those in component form. Alright, well, that's the only thing in contact with that, so the force free body is really pretty straightforward. Alright, right hand side, the center of mass is going to accelerate, so we're going to have an ma. That's going to be the acceleration of the center of mass there, g. That acceleration is going to be a tangential acceleration. Now, what we don't have is a centripetal term. If this were already moving, or already rotating, I should say, we would have an ma centripetal that would point up, which we could write either mv squared over r or r omega squared. But again, at the instant shown, this thing's not rotating yet, so I think I'd be tempted to just leave that off. You could put an ma sub y here if you wish, but what'll happen is it'll sum to 0 later. All right, now, in addition to this ma, however, this thing also is going to have a rotational acceleration, and I believe that's going to be in this direction. So we're going to have an I alpha term like so. Now, actually, whoops, I'm going to go back, and I was just thinking about the relative rotation of this. That actually is going to be, I believe, this way. I alpha, because this spot is going to basically start accelerating to the right, so in effect it's starting to accelerate clockwise. Alright, I think that's it. So now we got to write some force equations. Now if you glance this thing over and you start thinking about the unknowns here, that's an unknown, that's an unknown, this is an unknown. So we've got 3 unknowns here to deal with. We can write, well, and I'll say 4 unknowns. We can write 2 force and 1 moment equation for this problem. So that could solve up to 3. The reason I'm pointing that out is that tells you we're going to have to write some other type of equation aside from a force and moment equation. So force equation, sum of all forces x direction equals ma. That's a pretty easy equation. This force equals ma sub g. Moment equation. Well, there's a couple things we could do. We could do this, maybe some moments about g. That would give us px times r equals I alpha. Or we might choose to do something like, some moments about some other point. But I think that's a good one for now. Now, the thing is that the acceleration of g and the alpha, we got to figure out how those things are related. Remember that this point is accelerating to the right. I'm going to put that in red. That's not a force vector. I'm just drawing the acceleration of that point. That point is accelerating to the right 5 foot per second. And that's point A. So I'm going to go ahead and write out an acceleration relationship relating g to A. The acceleration of g is equal to the acceleration of A plus the acceleration of g with respect to A. The acceleration of A we know to be 5i, foot per second per second. And this term we can write as alpha cross r. Now I'm going to go ahead and do this in vector format. I've got this alpha counterclockwise. That's going to be minus k direction, crossed with the position vector g with respect to A. That points straight down. That's 2 feet in the minus j. So we got an equation here. It's going to be acceleration of g is equal to, I'm just going to put 5. Now when we do minus k cross minus j, we're going to get, let's see, 5. I think this is going to come out to be minus 2 alpha from minus k cross minus j. Minus k cross minus j. Yep. So now we've got a relationship between acceleration of g and alpha. So what we can do with that is maybe sub this here, and then what we're going to have is 2 equations, 2 unknowns for px and acceleration of g. And once you find any one of those things, this thing should fall apart after that. So I hope that this helps. One thing I want to point out, how do we work these problems? 1, draw a good free body, just like you've been drawing for almost a year now. Include a second part to the free body for the kinetic terms, all right, the MAs and the I alphas. If you don't know for sure whether there's an MA term exists, like here I talked a little bit about, does this thing have a MA centripetal? If you don't know, put it in there. What will happen is math-wise it'll come out to be a 0 if it's not actually there. Here I knew that thing's going to be a 0 because this thing's not moving yet. That centripetal term is an r omega squared term, but at the instant shown there is no omega. So, and then take note of this, that in a lot of these problems this is not going to be enough. You will also need some sort of kinematic equation, a lot of times relating the acceleration of one point to another, and that's what I did here. You notice that's a separate type of equation. This is purely about the motion of this object, and that will allow us to solve for 4 equations, 4 unknowns in this problem. So anyway, have fun with it, and I'm going to work on another video for you. Have a great day.